Alright guys, we're going to continue talking about quadrilaterals. We are going to finish through 9.5 for Christmas break. Today we're going to talk about 9.3 properties of rectangles, rhombuses, and squares. And that's going to be on pages 78 and 79. So you're going to go ahead and turn to 78 and 79 after you fill out your tab. Label them 78 and 79, 9.3. Move a couple of things here. .3 properties of rectangles, rhombuses, and squares. There is a nice mathematical debate, nobody's actually debating this, let's be honest, about the plural of rhombus, whether it's rhombuses or rhombi. You will see both. Properties of rectangles, rhombuses, and squares. That's 78 and 79's title. Now, there's going to be a lot of writing, just like there was in the parallelograms, but you will survive it. Because we are going to list all the properties of these pieces. Alright, first of all, a rectangle, rhombus, and a square are all parallelograms. That's something that's good to know, by the way. They're all special types of parallelograms. We're going to create a Venn diagram to show you that in a second. But first of all, let's talk about a rectangle. I'm pretty sure you already know what a rectangle is. The definition of a rectangle is a quadrilateral with 4 right angles. That's all the definition gives you. Important to know, as always, what the difference between the definition and the properties are. Just draw a rectangle. We don't have a lot of room, so we're just going to take up one line to draw a rectangle here. Like I said, I know you know what a rectangle is. Okay. Rectangle. It also has certain properties. So here are the properties of a rectangle. If a quadrilateral is a rectangle, then it is a parallelogram, which means if it is a parallelogram, which it is, that means that all of the properties of a parallelogram are true of a rectangle. The opposite sides are congruent, the opposite angles are congruent, the diagonals bisect each other. That's what this statement gives you. Okay. Also, something that is special to a rectangle but not necessarily a parallelogram. If a parallelogram is a rectangle, then its diagonals are congruent. That is the only extra piece that goes along with a rectangle. So in a rectangle, we know that the opposite sides are congruent, the opposite angles are congruent, the diagonals bisect each other, but if it's a rectangle, the diagonals are congruent as well. So that's your special piece there, okay, of a rectangle. Let's talk about a rhombus. You're probably familiar with a rhombus being a diamond shape is what you're used to. A rhombus, the definition is it's a quadrilateral with 4 congruent sides, and that's it. That's what the definition is. Okay. I'll draw a little rhombus here. 1, 2, 3, 4 congruent sides. That's a rhombus. It also has some properties. It is a parallelogram, which means opposite sides are congruent, opposite angles are congruent, and the diagonals bisect each other. Let me unfreeze me on the screen. I don't understand why it does that, but well, sometimes it just does. All right, if a quadrilateral is a rhombus, then it is a parallelogram. So you've got those 3 things about a parallelogram true, okay? But also, specific to a rhombus, if a parallelogram is a rhombus, then there are 2 things extra that are true. Its diagonals are perpendicular, so they meet at a right angle. And each diagonal bisects a pair of opposite angles. So a rhombus has a couple of extra things. This will help you, all of these properties and things will help you when we get to the proofs section of this. Scoot this down so you can actually see it there. There you go. All right, last, let's talk about a square. Again, I know you're familiar with a square, what a square is, what a square looks like. But we need the formal mathematical definition of a square. A square is a quadrilateral. In case you don't know by now what a quadrilateral is, it is a 4-sided shape. It's a quadrilateral with 4 congruent sides, like a rhombus, and 4 right angles, like a rectangle. Which means a square is a rhombus and a square is a rectangle. It is both. 4 congruent sides, 4 right angles. And let's list the properties. Now, since a square, by definition, is a rectangle and a rhombus, every single thing that's true for a rectangle is true for a square. Every single thing that's true for a rhombus is true for a square. Which means, no, I'm not going to list all these out. We're going to write in this form right here. If a quadrilateral is a square, then, first of all, it is a parallelogram. Meaning, opposite sides are congruent, opposite angles are congruent, and the diagonals bisect each other. Number 2, it is a rectangle. Meaning, the diagonals are congruent. Third, It is a rhombus. Meaning the diagonals are perpendicular and each diagonal bisects a pair of opposite angles. So everything that is true about a parallelogram, a rectangle, and a rhombus is true of a square. So a square's got a ton of stuff going on, okay? All right. There is a small little handout at the end of this video, or attached to this video. Is a Venn diagram of all these pieces here. And we're going to put this at the bottom down here. At the bottom of this page. We'll talk about it. Okay. A square, we have talked about, is both a rectangle and a rhombus, which is why it's in the middle here. It is both of those things. A rectangle and a rhombus. You will have to make a flow chart kind of like this. And one of your homeworks is either today's or tomorrow's. I think it's the end of the week. A rhombus has 4 congruent sides. It is a parallelogram. These are the definitions of each of these, by the way. Not the properties, the definitions. A rectangle has all right angles or 4 right angles. It's the same thing. It's just sometimes you'll see it as all right instead of 4 right, but that is the same. Parallelogram has 2 pairs of parallel lines. All of these are parallelograms. Now, something else that we are adding to this, I want you to box this in. Okay, we're boxing this in because we're going to talk about what all 4 of these are. All 4 of these are special types of quadrilaterals. Okay. All right, now we're going to actually do some examples. So now that you got that on page 78, if you have not titled 79, do that. And we're going to tear out page 448 from your textbook. It's going to be ripping that out real quick. We are going to use pretty much the entire page. We're cutting from the word example 1 to the bottom. Okay, so 448, we're cutting from the word example 1 all the way to number 6. And glue that in on page 79. All right, example 1, it says use a rectangle to prove the properties of rectangles theorems. That's talking about we're having to prove that the diagonals actually are congruent is what we're going to be proving. We will, in the process, prove it as a parallelogram as well, which are the two properties of a rectangle. These don't get special names because they're just properties, but they do put the word theorem behind them. Okay, so we're going to first prove it's a parallelogram. Then we're going to prove that the diagonals bisect each other, which is not bisect or congruent, which is why they've drawn this. They need you to know that, hey, we are going to use a triangle later, so to prove that AC is congruent to BD. All right, first of all, ABCD is a rectangle. Yes, we're given that. A and C are right angles. That's just the definition of a rectangle. The definition of a rectangle says that they are all right angles. Okay, then it skips ahead and says A is congruent to C. Well, of course, because all right angles are congruent. All right, and B and D are right angles. Same reasoning is the definition of a rectangle. And therefore, similarly, B is congruent to D because all right angles are congruent. You do have to have both 1 and 2, 2 and 3, 4 and 5. You can't just go straight to 3. You have to say why you know they are congruent. Okay. All right, so far what I have is that A is congruent to C, B is congruent to D. So therefore ABCD is a parallelogram. That's a property of a parallelogram. Remember the properties. One of them says if the opposite angles are congruent, it is a parallelogram. That's what we used right there. So I've proved the first part, that ABCD is a parallelogram, okay? Now I'm going to follow through and do the next part. I'm going to do that in a different color just to show you where it starts. So that was the first part right there, is all the way up to 6. The second part's going to be from here on out. All right, it starts with AD is congruent to CB. AD, we're using the triangle now, let's do that. AD is congruent to CB. And that says if a quadrilateral is a parallelogram, then its opposite sides are congruent. You would have written property of parallelogram or condition of parallelogram. I just want you to know that that's what you probably would have written, but it's nice to know that sometimes they just write it as an if-then statement, but I want you to realize that that's what happens sometimes. All right? Next, DC is congruent to DC. Why? Reflexive, they're in the same piece. Reflexive property. Now, just for you to understand where they are going in this proof, we are going to end up proving that these two triangles are congruent in order to say that their corresponding parts, AC and BD, are congruent. That's why you have triangles. You are going to use these triangle proofs all the time. That's why we learned them when we learned them. All right, D and C are right angles because the definition of a rectangle. D is congruent to C because all right angles are congruent. So we have side, angle, side. So triangle. ADC is congruent to triangle. ADC, BCD by the side, angle, side, triangle congruence theorem. That helps us because now we know that AC is congruent to BD because they are corresponding parts of congruent triangles or figures. You might put FC instead of TC. But I have now proved both. Those are these two properties. I proved that if it's a rectangle, it's a parallelogram. I proved if it's a parallelogram, if it's a rectangle, then its diagonals are congruent. We did both in this proof. All right, let's look at number 4. I want you to actually answer number 4 and then pause the video, answer number 4, and see what you guys put. All right, a student says you can also prove the diagonals are congruent in example 1, this green piece, by using the side-side-side triangle congruence to show that ADC is congruent to BCD. Do you agree? Okay, here's what we need to think about. We use side, angle, side. Is it possible to use side, side, side instead? Now, currently in this triangle, we have 3 sides. The problem with the student's logic, though, is that we were trying to prove that the third side was congruent. So we can't use that to prove that. So the answer is no. No. Because we were trying to prove that the third side was congruent. So we couldn't use it. You cannot use what you're trying to prove in the proof. It's like using the word in the definition. Okay, zoom in so you can see that, and then we're going to do 5 and 6. Okay, as is normally the case, 5 and 6 do not go together. Number 5 has certain measurements. We'll erase those, and then we'll do number 6, okay? So number 5, AD is 7.5. AD, 7.5. DC is 10, and we're supposed to find DB, okay? DB. So I'm going to, I got to find this diagonal. I'm going to label everything I know. Since it is a rectangle, because it's got 4 right angles, this is 7.5, this is 10, because it's a rectangle, it's a parallelogram, and opposite sides of a parallelogram are congruent. Okay? Now, here's what I want you to know. I am looking for DB. DB is the hypotenuse of this triangle. That is how I'm going to find DB. I have a right triangle. I'm going to use the Pythagorean theorem to find the diagonal DB. Pythagorean theorem, in case you have forgotten, is a squared plus b squared equals c squared. Remember, the only one of those that matters order-wise is c. C has to be the hypotenuse. db is the hypotenuse. So I'm going to replace a squared with 7.5 squared, b with 10, and I'm looking for dB. I'm going to type this part in my calculator. 7.5 squared plus 10 squared. That means dB squared is 156.25. So to find dB, I'm going to take the square root. Don't round anything. dB is 12.5. So I use the Pythagorean theorem. Pause the video to find dB for number 6 with those new measurements. Remember, these old measurements don't matter. So pause the video and try number 6. Okay, now that you pause the video. I'm still looking for dB in this situation, so I'm not going to erase the triangle I created. I'm probably still going to use it since I'm looking for dB, but I'm going to erase the values. Because my new values, AB is 17, which means DC is 17, and BC is 12.75, which means this is 12.75. Okay, and I'm supposed to find dB. So I'm going to be doing the same thing. A squared plus B squared equals C squared. So I'll scoot on over and do that. Actually, I don't have to scoot over. I didn't realize what you could and couldn't see. So 12.75 squared plus 17 squared equals dB squared. .75 squared plus 17 squared is, and don't round, 451.565. I'll take the square root. And I get that dB is equal to 21.25. I hope that's what you got. If it's not, you need to ask questions. Okay, our work so far has all been about rectangles. However, rhombuses could be the same. You've got diagonals perpendicular, diagonals bisect the opposite pair of angles, meaning the opposite angles right here would have been bisected if this is a rhombus. This is not. And a square has all of these things going on for it, okay? We're going to continue talking about rectangles, rhombuses, and squares the rest of this week. So go ahead and get started on whenever the assignment is posted.